This podcast is sponsored by Camera Museum of London and Tang Cigars of 44 Museum Street, London. Welcome to a Fish Out of Water podcast. This is your host, Richard Lipman. Today, we're interviewing Eric Wallin. This is part 1 of 2 of this podcast. Thank you, Eric, for joining us. Can you tell us who you are, what you do?
My name is Eric Wallin. I'm an electrical engineer. I have a master's degree in that. I worked in telecom for 10 years, and I quit at age 50 to work on a soft processor design. I can't believe my wife allowed me to do that. And for the last 12 or 13 years, I've been working on a digital theremin.
Can you tell us how that works?
Yeah, it's mostly digital. It has a little bit of analog electronics in it, but it's mostly digital. It's based around an FPGA, which is a field programmable gate array initialism. And an FPGA is like it's an integrated circuit that has like a sea of logic, all interconnected by a grid of switches, and you program those switches with a high-level language. So the FPGA in my Theremin has a processor that I designed running in it in the FPGA. And the processor, it also has peripherals for the field generation, the oscillators, for SPDIF output, MIDI output, that sort of thing. So you can design, full processors and their peripherals in FPGAs, and people often do. But FPGAs are they're rather power hungry and rather slow, so they're kind of a solution in search of a problem often. So.
Can I ask, is there any way you could show us?
The FPGA?
Yes, I mean all of it, like the design. I mean, start with the software or the hardware?
I have the hardware here if you want to see it.
Yes, please.
I've made about 50 kits now.
Can you show us?
Yes, I will.
Right,
these are the antennas that I give people, provide with them. They're kind of temporary. It's just aluminum foil inside of
Can you show us those the aluminum?
Sure.
Please.
Yeah. Just it doesn't really matter what you make Theremin antennas out of. I've had questions where people say, what if it's solid metal? What if it's this kind of metal? What if it's, it doesn't really matter. You can use tinfoil, from the kitchen. So here we have, it's kind of like the foil I'm using is a little bit thicker. It's sort of like something you'd find like a caterer would use, to cover up your chafing dishes or whatever. And I only use thicker stuff because it's easier to handle. Otherwise, I use the thin stuff.
What about using a what do you call them? Hangers, coat hangers, or metal?
You kind of want something that has enough surface area, and very thin wires and stuff don't have a lot of surface area, so they're not a very good match for manipulating the capacitive fields.
Right. Show us.
Yes.
Oh my God! Wow.
So this is how the kit comes. It comes in just a cardboard box, and it's mounted on a piece of corrugated plastic that I get from the hardware store. So here's the controller. It has 8 encoders, and it has an LCD that has 2 columns of 4 rows, so that each entry in the LCD corresponds to one of the encoders here. This encoder down here takes you to different pages. There are 20 different pages that you can adjust various things. You can adjust everything via the front panel too. That's one of my bugbears. I've had synthesizers before that require a librarian, and the librarian ages out, the operating system goes away, the electrical interface on your PC disappears, all sorts of things can go wrong when you're kind of relying on a PC to run another piece of hardware. This is the tuner. So it has 12 LEDs up here. Like this is C right here, C sharp, D, D sharp, E, F, kind of like that. So when you're when you stay on this inner circle, you're doing whole steps. And when you stay on the outer circle, you're doing whole steps. And when you transition from one circle to the other, you're doing a half step. So, and this is the volume here. Each LED is 12 dB. So when they're all off, you're pretty much silent. And there are grayscales associated with all of this too. So you have much more resolution than just an LED being on or off. The center LED here shows you whether it's muted or not. And this 7-segment display is for your octave. So on the back here, we've got, we have these coil boxes here. This is the pitch coil box. And inside of there is a hand wound coil. This is 1 millihenry. And the coil's inside here, along with a little circuit board.
What's its function?
These, when you stimulate one end of a coil that has a rather high quality factor, these have a very high quality factor, you get a much higher voltage on the other end. And a high voltage is really essential to a pro level kind of instrument because the high voltage then swamps the environmental interference quite a bit. It gives you very large fields that you can play fairly steadily. Right. So that's why I end up wanting my own coils. It's harder now to actually manufacture something like the Moog Ether Wave that uses RF chokes, because all of this RF technology, all the components are disappearing now with software-defined radio, things like that. They're able to get away from all sorts of tuned analog circuits with radio now. So you can't, it's getting much harder to find the parts to make something like an ether wave. So this right here is the FPGA board. Right. That's the FPGA itself.
What does that stand for?
Field Programmable Gate Array.
Okay.
So that's the C of logic part that the processors
interesting
instantiated in. So here's the USB dongle. Right. There's a little chip in there, so it goes from USB to serial. You plug this into your PC or whatever, or into like a charger, a cell phone charger, and that's what provides the D-Lev with the 5-volt supply. This also, you can communicate with a librarian software that I have. So the librarian lets you update your software, manage your presets, and do a lot of other things. So you can do diagnostics, you can do factory resets, you can do, you can morph presets based on chance, and come up with new presets on your own.
One moment, I'm just gonna be 2 seconds, just one.
Sure.
Oh, you forgot your gloves. You forgot your gloves. Yeah. And the ring. Oh man. Gloves and the ring. See you later. Sorry about that.
No, that's fine.
How many of those have been distributed or sold?
I've made, I'm working on the last 2 for 50, and about 3 of those haven't been distributed. And this is my kit. This is the 0, patient 0 here. was the very first kit.
There's been many different versions. What's the difference between each version?
There's really only been one version that's been distributed as a kit. There have been software updates that have come out kind of up until, I don't know, the end of last year, maybe even before that. The software is fairly established, and you know, it isn't going to be changing much, I don't think. And for one thing, I'm out of room inside the FPGA to really implement anything new, and I'm out of memory for the processor. So
there is one thing. I mean, how does one put this together? Is there a manual, or does it come in pieces?
It comes fully playable on the piece of corrugated plastic, like I showed you. All you have to do is plug in the little wires in the boxes, and hook those with alligator clips to whatever you're going to be using as antennas. So
What about the mounting? How would you mount?
Well, that's kind of the rub, it's one thing to build a kit. Each kit takes me about a week of work. And I've the kit building right now is kind of on pause for a variety of reasons. One of them is that manufacturing anything allows you to make the same mistake over and over, 1,000 times. So, there are things that not necessarily weaknesses, but that could be made maybe a little bit more robust. So that's kind of what I'm looking into right now. Instead of maybe a smaller, the coils like that are in the kit right now, maybe larger coils that would place the operating point below the AM broadcast band. I haven't had any issues with having it operate within the AM broadcast band, but and nobody else has reported that either. But theremins are accidents waiting to happen because you're exposing a very sensitive portion of an oscillator to the environment. So there's many opportunities, especially like 60 or 50 hertz hum. The mains electric field is very strong. So in the D-Lev, when you make a digital theremin, you have many opportunities for filtering that you don't have with an analog theremin. So I have like an eighth order filter, I think, before the notch filter that I have for the mains hum. And then I have an eighth order sliding filter on the pitch side to keep it an octave below where you're playing. So it's difficult actually to have a sensitive large field that's capacitive and exposed to the environment and have that be relatively noise free and also responsive. I mean, one thing you can do is filter the daylights out of it. I mean, like down to a couple of hertz, and that's what they do in the Theremin. They have a very weak, electrically weak field in the Theremin. Not to rag on it, but I owned one at one point, and I had to kind of look at what was going on with it. And then you can actually, your vibrato can kind of get lost in the because they're so heavily filtering that. I think they've corrected that to some degree with newer software settings, but that was before I got rid of mine. So. So it's a challenge to make a responsive instrument that
Tell me, does those electromagnetic waves affect the brain in any way?
No, it's though the D-Lev operates around a megahertz, which is maybe 2 or 3 times higher than most theremins. The photon associated with 1 megahertz is so weak that it's absolutely not anything you have to worry about.
I was told that there's a sound of water in terms of hertz. Is that correct? Is that achievable with the theremin?
A sound of water? I don't quite know.
400 and something.
There is that. I think there's something called the water hole, and it has to do with radio telescopy or whatever. It's anyway, but no, that'd be up in the gigahertz. So
okay. Is there any chance, Eric, you could demonstrate
sure.
the sounds?
Yeah. So one of the things I've always wanted to do was design and implement a music synthesizer. So this is my opportunity, and it was interesting. My goal was to do somewhat realistic human vocals with it, and that was the main goal. But it turns out when you have the synthesis in place to do human vocals, you can do a lot of other things too. So there are no samples or anything inside the D-Lev. Everything is synthesized. And it's kind of the opposite of what you think of, like with a Moog synthesizer. Like a Moog relies upon rather complex waveforms to generate a complex harmonic structure. And then it uses rather simple filtering often I'm talking about like a mini Moog. he uses like, that low pass resonant filter to, everybody's very familiar with these sorts of things.
I mean, can you give us an example of how it would sound?
Of what a Moog sounds like?
Yeah, I mean the low pass filter.
Oh, well, I have like a wind preset that, and I don't know if original sound for musicians, I guess I'll turn that on, or do you turn that on? Oh, I turned it on, okay.
That's you.
Okay.
There's a little bit of a hiss.
Is there?
Yeah, tiny bit.
Does that help?
No.
It could be the refrigerator. Is it?
Really?
You want me to go turn the refrigerator off?
Sure, if you think it'll help.
Okay, just a minute.
It's a sort of buzzing. It's a crackling sound. Yeah, a little bit better. Sorry, folks, we'll be back right now. 1 moment. Oh. Goodness. Adjusting the microphone.
Does that help?
Definite improvement. Yeah.
Okay.
It's about 40% improvement.
Okay.
Less hiss.
Let me make a note to myself to turn the refrigerator back on. Okay. Hey, what's wrong with our ice cream?
Oh, well, what's that in the background? I see there's 3 women here. Are they related to you?
No, that's Teresa Correggio. She was a composer during the time of maybe Chopin. My wife is a pianist, and she did a little sort of impromptu concert. Well, not impromptu, it was planned, but yeah, it was more of a she thought it'd be more of a background entertainment thing, but it turned out to be more of a watch me play kind of thing. So yeah, her stuff is very Chopin-like. She's an interesting composer. So I have a wind preset, I guess, that shows like that sort of So
okay, let's hear it.
Well, one thing that's interesting is, yes, I'm sorry.
You have presets, right? Is that correct?
Yes.
You
Yes.
have the normal sound as well of the Theremin.
Yes. Several people have sent me samples of their various Theremins. So I have several for the Etherwave Pro. I have several for the Clarivox. These are both Moog instruments. And for the Moog Melodia, I have several presets. I have presets for the T-Vox Tour, for the Hobbs, and also for the Subscope. So yeah, so you can play, analog theremins on a digital theremin.
Fantastic. So the D-Lev stands for digital, am I right? What does D-Lev stand for?
The Lev is for Lev Theremin, in honor of him.
Have you ever met Lev Theremin?
No. He, I could have, I guess, at some point, but I wasn't doing this project at a point when he was still alive. Yeah. It would have been interesting. I mean, I know Rob Schwimmer, a thereminist, lives in Brooklyn, and I think he talked to her on the phone, I think, at one point. I talked to Clara Rockmore on the phone. She was in the phone book, and he called her. Rob was the first thereminist, kind of big thereminist, to world-class quite type thereminist to get a D-Lev. And so he's been over here many times with other thereminists, giving us little concerts. he was here with Katice Ilyani. She's Hungarian, very, very good thereminist. They're both excellent thereminists. Rob is incredible too on piano. I'm going to see Gregoire Blanc next month. He's scheduled to play here, and I'm hoping he'll swing by. Carolina Eick was here a few months ago, the great Carolina Eick. Lydia Kavanagh has a kit. Anke Martin also has a kit, and Charlie Draper has a kit. So those are the, it's really, really wild to have to watch your instrument on stage. When it happened the first time, I almost couldn't watch because you're waiting for something to go wrong and it's all your fault. Now I've gotten to the point where I can stand it now, but it was kind of cringe time. So anyway, so when you synthesize human vocals, you need about maybe 6 to 8 resonances to do a human vocal. And it's interesting that you can sort of rank natural sounds by how many resonances they have. Like a horn has maybe 1, a human vocal has 6 to 8, a violin has maybe 30 to 100. A cymbal has maybe 1,000. So it's and so the D-Lev only has 8 resonances that you can use. But I also have an inharmonic resonator, which you can use for formant fill, and you can do a lot of other things with it too. It's a really interesting and very versatile construct to have.
Would you say it's the most? Would you say it's the most versatile digital theremin in the world?
Yes, I think so. I've spent a lot of time linearizing the fields, so the pitch field is very, very linear. I can show you that.
Yes, please.
So you can play it all the way to the antenna. And with analog theremins, it usually gets very squirrely the closer you get to the antenna. Right. And the antennas tend to be not insulated. They tend to be bare metal. So when you touch them, you generally get a kind of a nasty squeal. Yeah. So people tend to not play very close to the antenna because of the nonlinearity and the squealing that's possible. And also, you don't want to disturb the whole unit. But then that's really unfortunate because you have the absolute most control the closer. When you're right at the antenna, you have an incredible amount of control because the calibration is really just for back here when you're playing far away. The closer you get to the antenna, the less the calibration really matters. So, I tend to play really close. It's not as impressive for the audience, but not that I play to audiences, but it's just a fact of how the physics and everything works. So I've linearized the pitch field. It's, I think, more linear than probably any theremin. And the volume field, after you linearize the volume field, you'd think you'd be done, but you're not. It's, I think the volume field gets a lot of short shrift from theremin designers. Not that they're all bad or anything, but what you really want is, there are so many sounds, sort of like when you're singing, you can only sing below a certain kind of volume, and then your vocal cords just start vibrating. So there's some nominal volume you have to kind of get up to just to have, producing a sound that, and then above that you want a more, an expanded region for your hand to be able to control the nuance of that. So you want to shape the volume field to allow for that sort of thing. And then, if you're doing a horn or something, you really want it to come in and blip a little bit. Or so I have a couple of nonlinear, I have a knee that you can adjust the lower portion and where the location is of the gain break. And then I have a second order kind of curve that you can apply to it also. And then I have a velocity component so like the faster you kind of attack it, you get more of a velocity, and velocity is built into some of the better theremins. So, but I haven't really seen where people intentionally put kind of a non-linearness to the
Can you show us some examples of what you mean when you talk about the settings and the linearity? Sure.
Please. So here's a female vocal. Okay. And what's cool about vocals is like The theremin's kind of spooky anyway, and then when you're doing a human vocal with it, it's like doubly kind of spooky. Anyway, so let me show you the linearity. First, I'll do an auto calibration. So this is what you do. Instead of adjusting the pitch and volume knobs on a theremin, you press this encoder right here, and you stand in playing position, but you pull your arms back, and you wait for it to auto calibrate. So I press this button. Okay, now it's auto calibrated. So it's very easy to, once you have the field set up the way you like them, to get them back to the same place every time. So, let me show you. I set my pitch field up so it's much more relaxed than an analog theremin. So I can kind of stand at it easily, I can breathe, I can do things like that, and it doesn't really affect the pitch much. Mm-hmm. So I have it so that an open closed hand is about 4 half steps. So here's. Almost.
What do you mean by steps?
Like
when you're playing
musically, 4 half steps.
Yeah, in connection with the theremin. Can you show us a step?
Okay, like from C to C sharp is a half step, yes. Right? So from C to E is 4 half steps.
Right.
So it's like here's E, C. So that's 4 half steps from C to E.
Right. And what a step is
C like C sharp. Oh well, C to D is a whole step.
Right.
C to C sharp is a half step.
Got it. Now in terms of the how many presets are there?
250.
250. Can you add more than that? Can you create custom presets?
You can put whatever you want in whatever slot. So it's, and right now I have up to 210, slot 210 filled with various things.
Now tell me, do you just dial the button to change the preset?
Yeah. So here. You just go through.
Can you show us a preset that's very recognizable in terms of the human ear? Or musically?
Well, let me just, I'll do some human vocals, and then I'll do some other stuff.
Please.
Okay. Let's see. Let me see. So this one, this is a song that Rob Schwimmer plays, and it's really, really pretty. It's called Lotus Blossom. Sorry, I'm not a real professional player.
Okay.
Let me try it again. Star Trek theme. You can see I'm actually going right to the plate there.
Yeah. Tell us, how do you know a scale?
Well, it's when you have a very responsive tuner showing you what the note that you're playing is. It's kind of like paint by numbers almost, because you're just looking for patterns on the tuner, and you just I'm watching the tuner like a hawk.
Would you say it's one of the most difficult instruments to get good at?
Yes, I think in particular the analog theremin is notoriously difficult to play. And I think that's because, well, I have this theory about any musical instrument or musical controller that what you want to do is use the minimum amount of movement to do whatever you're going to do on the instrument, but not too little, you know. And I think that on the analog theremin, the pitch field is too tight. That's my feeling. And that's kind of what repelled me from the instrument kind of initially. And I think the volume field is often too loose. So you see people making these very large gestures and quick gestures, trying to get, you know, a staccato out of something, and many theremins can't. Well, not many, but a lot of theremins can't do staccato very well. But that's why you kind of have a loop for the volume. It's like, so you can get a large kind of capacitance change by putting your hand in and out of the loop.
Can you show us a staccato on the D-Lev here?
Yeah. I mean, like the, like that, or maybe a trumpet.
Yeah.
Let's see. I like the flugelhorn better than the trumpet. No, sorry. All right, sorry. Let me do Tony. Heck of it. There's okay, a viola and
It
cello.
sounds very violin, yeah? It's got a violin. Godfather thing. I can see it's very controlled. There's a lot of control that goes to it, right? You've got to be very precise.
Well, When you're watching the tuner, yeah, that I think really gives you, you have no tactile feedback with a theremin, so you're kind of relying on muscle memory. You might be relying on things like fingering methods to kind of give you the jumps. But when you have a tuner, you can come in on pitch very easily, kind of wherever you want. So the large kind of jumps, pitch jumps that you normally have to train very heavily for on an analog theremin are really easy once you have a tuner. So and I also use pitch correction. It has pitch correction built into it. You can defeat it if you want to, but I think if there's any instrument that's crying out for pitch correction, it's the theremin. So some theremins like the Theremin or the Clairvox have pitch quantization, and all that is like it kind of introduces hard or soft steps in the pitch field. And if you just slow down that correction, then you're 90% of the way there with pitch correction. And then there are a couple of other features that I've put into the pitch correction. One is center note modulation. So the closer you are to the center of the note, it speeds up the correction rate. And the farther away you are, or the more you're between two notes,
can I
call you?
Sorry, can I call you
Sure.
back in 10 minutes? I'll
Sure.
send you another link. We're going to go into that in a second.
Okay.
All right, thanks. This podcast is sponsored by Cameron Museum of London and Tang Cigars of 44 Museum Street, London. Thank you for listening to a Fish Out of Water podcast. This is your host, Richard Lipman. Should you have any questions, comments, or suggestions, please get in touch.